Okay, so we're going to take a look at the iron carbon phase diagram and one of the questions from previous test. In fact, it would be the December 2010 exam, question number 4. So I've sketched up the iron carbon phase diagram, and of course on the exam the axes would be labeled and the compositions and temperatures would be indicated as well. But let's just start off as a quick review by drawing those on ourselves. So first of all, we've got the temperature axis. Along the x-axis, we have composition. In weight percent carbon. So remember, the composition axis is in weight percent of the component on the right. Now in this case, with the iron carbide phase diagram, we actually stop at a composition of 6.7 weight percent carbon. We don't go all the way to 100% carbon, which is way over there, because this is just the interesting portion of the phase diagram. So next thing we could do is actually label the single phase fields. So on the far left, we have the single phase alpha region. A little bit higher temperatures, we have single phase gamma. Even higher temperatures, we have the liquid. And on the extreme right, at 6.7 weight percent carbon, we have the intermetallic Fe3C, or cementite. Let's label some temperatures. The eutectoid is at 727 degrees. Let's label some compositions. The maximum composition of concentration of carbon in ferrite is 0.022 weight percent carbon. The eutectoid composition itself is at 0.76. And the maximum solubility of carbon in the gamma phase is at 2.14 weight percent carbon. And that occurs at the eutectic temperature, which is 1147 degrees C. Okay, so when we look at question A, it's asking us if a certain composition is possible. First thing to realize is there's a few hints in that question. At the very first part of the question, it tells you it's hyper-eutectoid steel. There's two important words there. Hyper-eutectoid tells us that the composition is above the eutectoid composition, so it's greater than 0.76. And the other word there, it says it's steel. It has to be less than 2.14. Above that, we know that's cast iron. So we actually have a composition for steel between 0.022 and 2.14. The question also tells us it's hyper-eutectoid, so we say in fact it's between 0.76 and 2.14. Okay, so we're going to tackle part A. What I've done is I've just redrawn the phase diagram with the important compositions and temperature indicated over there. So, as with any phase diagram question, we're going to start off with what I call the coordinates, or just the temperature and composition combination that's given in the question. So in this case, the question tells us 725 degrees. So we know we're below 727. And it doesn't tell us the composition yet. But if we're below 727, we're in the two-phase alpha plus cementite region, and we're going to draw our tie line. Again, as soon as we realize we're in the two-phase region, we're going to draw a tie line. It confirms that we've got ferrite and cementite. Then the question tells us that there's 760 grams of ferrite out of a total 1,000 gram sample, which is actually the result of our lever rule calculation. So now we can set up on the other side of the equation the lever rule itself. So we're in the two-phase, alpha plus cementite. We want to determine how much alpha there is. So we take the opposite side of the line, 6.7 minus the composition. Now remember, we said the composition is going to be somewhere in here. We don't yet know where it is. We'll call it C naught, overall composition. Over the total length of the tie line, 6.7 minus 0.022. So we can just do some simple math. Okay, so I've brought the denominator up, just turned this into a fraction, brought the denominator up, brought 6.7 across, and we'll eliminate the negative sign, or multiply both sides by -1, and then we can calculate directly what C naught is. So it turns out C naught is going to be, I'll just do one more step, 6.7 plus, minus 0.76 times 6.7 minus 0.022, which equals 1.67 weight percent carbon. So we said before that it had to be between 0.76 and 2.14. So yes, sure enough, that's correct. So we can answer our question. We can say yes, it's possible, and this is the composition.